Okay, so let me just review what I did so far. I gave out 3 sets of practice problems. We did the first page on one of them and we went over those, and I will post that on my Yola site. I didn't record all that. Now we're going over the 2015, 2016 test, and that's always so way low on there. And we're going over the page 2 problem, and I want to go over this with everybody just to kind of make sure that you have a good opportunity. You know, these first 3 problems, the first 2 pages, are pretty much identical except for changing the numbers. Someone requested maybe that I make a problem bigger of that second one on the bottom of the first page, and I'll try to do that so that you can kind of write some things on it. So these first 3 problems in the 2 pages, they are ones that pretty much the expectation is that everybody gets it right. And I'm going to give you a super huge hint on this very first one at the very beginning. It is a quadrilateral. It has 2 right angles and a given angle. So you can find that 4th angle, which is angle BCD. But also, what you want to know is it has this dashed line across it, but in order to attack the problem, you actually have to draw in the other diagonal. Well, and that was a pretty bad line, so I just feel like I'm going to do that over again. Ooh. I'm going to try to do that over again. That's what I'm going to do. So I will just redraw that a little better. And so that's what you have to know. You absolutely must remember that that's what you have to do when you first attack this problem, is draw that in. And so I'm going to go through this using the stored features, and I'm going to write on here the letters that I stored things as. The distance of BC is A, so if you would take a moment and store this as A, so 815.05, press that store, and alpha A, or yeah. And then the segment CD is capital B, and so if you would type in 374.09 and store that as alpha B, that would be good. And then this big angle that's over here, 86 degrees, 30 minutes, and 35 seconds. How are you doing that? Divide it all out and store it. Okay. So when you type that in on your calculator, just 86 plus 30 over 60 plus 35 over 3600. I don't know if you do enter first, and then store that as alpha C. Because we're going to have to draw from those, you know, repeatedly as we go through this. So the first thing you want to find, and essentially you have to find only distances. So all of the angles that you find, you don't have to change them into degrees, minutes, and seconds, and you're just going to store them as a letter. So this is a quadrilateral, the whole shape, and I'm going to call this other big angle here angle D. And to get D, I'm going to take 360 minus 180 minus capital C, and then I'll go enter, and I'll store that as D. I laughed at myself because there are 2 90-degree angles, so instead of going 360 minus 180, I could have just used 180 minus C, but that's what I did. And then we don't really even care what D is, as long as we've stored it in there appropriately. Now for the next thing, and I'm going to call that red line that I drew in, I'm going to call it capital E. And I'm going to use the law of cosines to find that. And I'll just kind of remind you for the law of cosines, and I'm going to erase all the yellow, but I've got this side, that side, and this angle. So I can go directly to finding E, and on my calculator, I would just say E equals, I would just type in big square root, and it's just going to be alpha A squared plus alpha B squared minus 2 alpha A alpha B cosine alpha D. And do make sure your calculators are in degrees. But they probably already are if you've been working on these problems now. And then when you get that, just store that as E. Now notice that is not something you are asked for, so I'm just telling you that's what you start with because you're going to do what you can do. Yep. 917.26. If you got 917.26, you're on the right track as we go. Now, the next thing I found in this one, and it's debatable what you're going to find next, but anytime I write in yellow, then I'm going to kind of get rid of it. Then I have this triangle, and I can get either that angle up there or this angle down here. I chose to get this angle. It doesn't matter which one I choose because I can find the other one if I need it or whatever. And so I just chose to find this angle down here. I'm going to call it angle F. And actually, I'm going to call the one next to it G because I will have to find that angle G as well. So, but to find angle F, I'm now going to use the law of sines. So I'm going to say capital A over the sine of F equals um, capital, or excuse me, capital E over the sine of capital D. And then I'm just going to figure out what F is. Can I go directly to F? Are you good with that? So F is going to be the inverse sine of A sine capital D divided by capital E. And by the way, remember that these are all identical problems. So if you do set this up like this and write all these letters on here, really you can take your picture of this one that you've done in class and use that as your notes on the test. So you don't even have to recalculate that. Do you know what I mean by that? You can just say, oh, I know F is going to be the inverse sine of all this if you put them in your calculator in that same order. Does that make sense? They are your notes. Yeah, you can just take them as to the test as notes. And that freaked me out kind of the first time, but there are students who will have these as notes and you are allowed to use them as notes. So then I got a 62 degrees, 29 minutes and 18 seconds because I do write them in that. And then don't forget to store that answer as F. And I write myself a little note, store F, because sometimes I forget. Do you know? 62 point what? Probably. I got. Um, I called that as F. Stored it as F. And then what's G? I mean, how do you get G? Yeah, G is equal to 90 minus F, and then store it as G. And I have 27 degrees, 30 minutes, 42 seconds, because I just, I find them as degrees, minutes, and seconds just to have it that way. So now I've got that angle G there. And really, I wasn't even asked to find that, but I am asked to find segment AB. And that's the next thing I'm going to do is find segment AB. So, and I'm changing colors a lot, A, B, C, D, E, F, G, H. So that's going to be this first answer, and I'm calling it H now. And I'm going to use the law of sines again. So, H over the sine of capital G equals And on this triangle, I'll use yellow a second. On this triangle, I have this angle C that I put in there I've not used yet really for much. And I've got that side E, because so it's kind of back a little ways to kind of scroll through. So H over the sine of G is equal to E over the sine of capital C. That's an E. And then it's H that I want, so H is equal to E sine G over sine C. And then store that as H. I want to know what H is because it's an answer on the test. 50 exactly. Yep. And I'm going to write that I called that H because that just helps me know what I did there as I go. The next thing I want to find is AD. And I'm going to use kind of a color I haven't used before. I'm going to use this kind of bluish color. And I'm going to set up the same thing here. I'm going to call that I. And that's an answer that I want as well. And so this one, oops, no, I'm not calling that I. Darn, I'm sorry. I'm calling I this angle over here that I decided to get. And I got that angle by taking 180 equals 180 minus G and minus C. And then I stored that as I. And that's going to help me get my next answer. Then once I have that, then I'm going to get this other angle here. And for that one, I'm going to call that J, and that will be an answer that I'm giving. And I'm going to say J over the sine of I equals that same C over the sine of capital E. Oh, yes, it is. Thank you. My bad. E over sine C. Actually, I wasn't paying attention to what I was doing because I was looking, oh yeah, I was looking for it earlier. There it was. And I wasn't finding it. So then J is equal to E sine I over sine C. Somebody could let me know what they get for J. Nope, it's 800 something. 839.38. Did you get I in the mid? That one should have been, and that's J, and it's 839.38. And then AC is the other distance you have. That's actually on a right triangle, correct? And so, and I don't have to store anything because it's just going to be an answer. Then for that one, I'm just going to use one of those right triangles, and I'm going to say, what are those sides, B and J? I'm going to say that AC is the square root of B squared plus J squared. And what do you get for that? 918.97 for that one. 918.97. And yep. BD. BD, oops, I have my rounded number 917.26. So now the deal is that's an involved problem, but it's the same every time. What it, um, oh, and if you, okay, and I was going to say, if you want to check what you stored something as, I think you can just go alpha that letter and then enter and you'll see what it is. Now, I'm going to the next page, but I'm not going to go over the problem. Um, and I don't know that it's last year's problem. No, it shouldn't though, because when I did this one, it's just more of the same. I'll just say it that way. It's more of this problem, this particular one. Some other years they've been a little more complicated, but this year it was just all the same kind of things. Right. So like for what did I put this in as my A, and so I'm just going to go through it, and this will be on my Yola site or whatever. So I called this A. And this is another one where it's a little tiny to write things in. I called that B, this 30.00, A and B, and I don't even see a letter C that I might have done. Oh, I somehow, oh, I must have put those in, but then I started working over here, because I did it as a student. So what I did is I drew in this diagonal and I called, huh? Oh, um, my gosh, this is like this. 100 equal minus C. So this, how did I, oh, okay, so I did find this angle B, right? And then this angle is a right angle. And somehow I knew that. Oh, because it's a rectangular building. This is a building. So then I went to this, and then if that's 60 and this is 80, do you agree that this is 100? Are you with me on that? The Pythagorean theorem. So I can do that as the Pythagorean theorem. So right, this is the square root of 60 squared plus 80 squared. So it's 100. And these are right angles because it's the building, right? Correct? Yes, and that was distance AC 100. And how do you have to write it? 100.00. And then I could find this E again. Oh yeah, I did do that way. I did this little tiny picture. I'll circle it in yellow. This little piece, I did it just like the previous page. Are you with me on that? The previous page. So I drew in that line and I called it E. And I went through that process because I know I could find angle B because that's a right angle. A right angle, this is the 93. And so that angle B is 360 minus 180 minus angle A. And so I could get that angle B because I didn't even write down what those are. So that gets you kind of a little start on these. Don't be intimidated by them. Just start drawing. Yep, just start drawing triangles and start kind of looking for things. I probably will spend another time, partial hour going through these during this time.